This is Jacob Hawkins, and I'm presenting on our 8th and final interactive advanced concept presentation for General Chemistry 1. So this week in class we've been talking about phase changes. So a phase change is a change in matter from one state to another. So you could have a phase change that could involve a liquid turning into a gas, or a gas turning back into a liquid. You could have a solid that melts and turn into a liquid. So it's just the change in the state of the matter. Now these phase changes can occur when energy is either added to or removed from a system, or when pressure is applied to that system. So the easiest example to think of would be water, right? Because we all know that with water, if we add the right amount of thermal energy to it in the form of heat, then water can turn from a liquid into a gas in the form of water vapor. Or if we were then to take that water vapor and remove thermal energy from it and bring it back down to a colder temperature, then that turns back into a liquid. So I've included over here on the right a graph that kind of shows you how water will change its state based off of thermal energy that's been applied to it. Now we are going to actually demonstrate these different examples in an experiment where we're going to be making different forms of instant ice, and this will kind of demonstrate how phase change occurs with water. So I'll explain it a little bit more in the video, but one thing that I worry I didn't necessarily make very clear in the video that I just kind of want to say, because it'll become relevant when we kind of discuss the chemical things that are happening on the last slide, is that the water that I was using had never been opened, so that way we ensure that it's very, very pure. So it was distilled water, so there should be no other material in those water bottles other than just water. Hi, this is Jacob Hawkins, and I'm presenting on our 8th Interactive Advanced Concept presentation, also our final Interactive Advanced Concept presentation for General Chemistry 1. So this week in class we've been talking about phase changes, and we are going to demonstrate phase changes of water doing an instant ice experiment. So essentially the setup is I have 3 bottles of water that I've placed in the freezer to bring them slightly past the point of freezing. However, they've remained liquid, and it's water that I've never opened before. It's distilled water coming in a bottle, so it's as pure as water can get, essentially. So we are going to be doing 3 different experiments making instant ice. So I'm going to be moving back and forth between the freezer just because I want to make sure that I keep those the bottles of water at as constant a temperature as possible. I don't want to bring them out because then obviously if I leave them out too long, the temperature can rise. So I'm going to go get the first bottle. And I have found that you need to bring these out very, very slowly, because if you disturb them even a little bit, they will instantly turn to ice. So I have a bottle here that is still liquid, but it's very, very cold. So what I'm going to do is, and you can see ice is forming. And kind of the more that you disrupt it, the more ice forms. So I don't know how well you can see with this lighting in the camera, but you can already see when I do that, you get ice crystals that are kind of running the length of this. So now it's more of the consistency of, I would say, slush than a liquid. I can even, for the next experiment, I'll need to do this anyway. Okay, so I'm going to pour out some of the liquid that's still in there, and you can maybe see the crystals that have formed. So now what I'm going to do is I'm taking also, that's water that still is very, very cold. And what I'm going to do is I'm going to take an ice cube, and supposedly if I put this and just touch the tip of it, the crystal of the ice will kind of diffuse and spread across the liquid. So let's see what happens. So not so much. I mean, there are ice crystals on the surface, but I can't tell if that's from what I poured out, because the majority of this is slush. So that could possibly be it, that I'm just pouring those ice crystals that were already in this from the first slamming experiment in there. But we're going to do something else where I have some ice here, and I'm going to take another bottle of very, very cold water and pour over. And what should happen is ice will kind of pile on top. So let me go get that. And And again, you have to be very, very careful with this because already just slight movement, and I'm noticing that ice is forming in this bottle. So I'm kind of impressed by how well that actually works. I didn't really think it was going to when I first tried it. All right, so I'm going to slowly pour this over, and you can see, slush forms. I'm going to get my apartment completely wet. Oh, and what's interesting is that actually that slush traveled all the way up to the bottle. You can tell the temperature is at this point probably come a little bit too past the point of freezing. All right, so 2 out of 3 worked with those experiments. So on the next slide, I'll kind of explain what's happening behind the processes from a chemistry standpoint. All right, so let's kind of dig into what was happening with those experiments. So the kind of takeaway from all 3 is that phase changes can occur rapidly, and this is obviously demonstrated most visually when we took that water bottle and we slammed it against the counter, and ice instantly formed. So basically, when we had that water, we can assume that the temperature was probably a little bit past the point of freezing, but because that water was very, very pure and there was nothing in it, this allowed that water to stay at a liquid state without crystallizing. So then what we did is we suddenly disrupted the system by slamming it on the countertop, and that occurred that kind of rapid formation of the water crystals. Now, kind of in more specific terms, when water freezes, it goes through, the first thing that it goes through is something called nucleation, which is the initial process of the phase change when molecules are being rearranged to form the beginnings of crystals in a solution, liquid, or vapor. In our case, obviously, this is liquid. So that's kind of the initial phase. And then by having that sudden disruption, that just happens, it spirals out of that very, very quickly. Now that was at least for the first experiment we did. The last experiment, which was also successful, where we poured that hyper cold water over onto a pile of ice. I actually think what was happening there was more, you already had an existing water crystal, and then when you poured that water over it, that water is already kind of ready to form crystals, and by being exposed to another crystal, those molecules are already primed and ready to kind of quickly rearrange into a crystal structure, and then we saw that kind of the slush form on top of it. Now for the second experiment we did, where I tried to take water and drop an ice cube into it and then have the whole cup basically freeze quickly, I think probably what happened is that by that point, because I'd already been playing around with that water for a little bit, probably the temperature had just come up to past the point of freezing. So that just wasn't going to happen. I think if I were to redo this experiment, probably what I would have done is, rather than pouring that water out from the first experiment, I would have just had a separate bottle of water kind of primed and ready to conduct that right away.